Hello and welcome to my workbench. This is VT and I'm going to do a short video on, well, what I do, which is electronics and inventing, or not really inventing new things, but you could probably call it that. I mean, this ominous black square you see taking up most of the freaking screen is what I call the APU, or Auxiliary Power Unit. Oh, and yes, it is currently powering this light here, so it may have flickered, but so you can actually see the interface. It's actually got a bunch of switches and LEDs and a knob in the light, by the look of things, and yes, that is a light, which looks like a fluorescent, which was the entire idea behind the fake fluorescent, which I learnt from Quantset's LED pages. Now, this is a rather interesting device. I mean, I made it for a TAFE project, which is Australia's equivalent of a not a university, we do have universities, but college. That's it. It's Australia's equivalent of college, which is TAFE. And yes, the particular technical TAFE I attended was the last one in my city that was doing a electronics course. Although they seem to have opened up a couple more of them these days, electronics courses were actually on a decline a few years ago, with it being rather difficult to attain a position to get a qualification in this. But that's a story for another day. This is today's story. So this is the back of the APU. As you can see, there's the plug coming out of it, and this is the what powers that light on the top. Let's quickly turn it on so that you can see that, yes, when I plug this in, that light comes on, because that's the auxiliary power out, hence the name Auxiliary Power Unit, as it contains a bunch of lithium batteries and allows me to power just about anything from just about anything. This has two different types of output. There's this, which is the 5-volt output, which actually goes to a little connector for charging the phone and things like that, or I could just have put a USB port on there, but I wound up using this dinky little 2mm jack, I think that is. Yeah, dinky little thing, but it does the job. Provides the connections for the 5-volt. And this is that plug on the back, which is a 3.6 volt, which is connected directly to the batteries inside, pretty much. And then there's, of course, that little light that we could see, and an amplifier, which, well, this thing's basically got it all. You can play music, turn on a light to see at night, although when it's fully charged, I would not recommend turning on the light. Ow, my fucking ears. That is an absolutely terrible sound, which is being caused by the light's power supply, basically oscillating and causing interference in the amplifier circuitry. And this is all the simplest circuitry I could fit inside this box, so it's not exactly, it doesn't exactly have the best common mode rejection ratio or any other important factors like that, but this is literally just an experimental. It was to test the concept of whether or not I can create my own power bank, but have an amplifier and a light source in it, and have these things running more or less independently of each other in such a way that that's why you see two lights on the front, because each of these corresponds to one of the batteries, this side being the main power supply, which serves both of these switches, and this side being the backup power supply, which serves the amplifier and light. So no matter how much power I pull out of the main power bank, it'll still have 1.5 amp hours fresh to go, so long as this wasn't used during that particular period of time. Now, what I think is the best thing about this device that I've made is this. This is the input for the, and status display for a power supply that's in the bottom here, which I made pretty much entirely of my own design, that I call the Ditto power supply, which means that it can take any voltage in and pump out the appropriate power for the battery. So I can plug a 12-volt battery in here, or a 6-volt battery, or plug it into a USB port, or even just use other random lithium batteries and even AA and AAA batteries if I wanted to provide a little bit of power to charge up the internal batteries of this, making it pretty much one of the most ideal apocalypse devices that anyone could make. Now, if I had some batteries to test it, well, I do have a battery to test it with, but let's just see if I can prop this up on its back without it flipping out, and see if I can find a misplaced connector. Here it is. So, that is it plugged in, and after whacking everything about, I'll just quickly demonstrate that it does indeed do stuff. So there's the red lamp showing that it's stepping up, and it will do the same thing when I plug it into a lithium battery. Sometimes it lights both the red and the green, but in this case it'll just do the red because it's pretty much fully charged. And there goes the focus because it decided I'm going to focus on a wire rather than the subject. Oh well, that is the phones. Let's see if we can force it to lock onto something. That might just mess everything else up. Yeah, have to refocus it or just turn autofocus back on. And yeah, so this, well, I didn't plug it into a 12-volt battery, but I'm fresh out of 12-volt batteries to try it on. Well, I do have a fang-dangle little power supply here that I could probably just disconnect this battery and set it to, we'll just give it 9 volts, because it does the same thing for 9 volts, 10 volts, 12 volts, whatever you decide to plug into it. 12 volts being the acceptable maximum. Putting any more in it than that will cause it to get quite hot and smoky pretty fast, or maybe after a while, but still, it's not something you want to do. But, unhappy power supply. Sometimes that plug will short. Not enough current. Duh. The simplest mistakes. And yes, there you go, the green light telling me that it's stepping down rather than stepping up. So it will show what it's doing as I'm doing it. And yeah, it is pretty, hang on, I'm just putting all this away. It is a pretty fascinating device. I mean, being able to charge it from anything like that is a very handy thing to have, especially when you're out camping or doing anything that really requires power, I guess. I don't know about camping requiring power, but people like to have lights and stuff, so yeah. Let me just put this, I've got batteries on charge everywhere. But I'm currently doing a test of 100 batteries, because I have more lithium batteries than I can count. As you can tell, I've probably got about 100 of them. I think it's more on 120 since I've got a few more that have come through over the past couple of years. But I want to get rid of them. They are literally just rolling around everywhere, like this one is, hanging around on the bench, or that one was just recently finished a test, so that's why it's here. But the others are just getting in the way. They're all over the place and just scattered about, really, taking up a lot of space and not really being of much use. So I've decided I'm going to put them to use and put them inside of a massive version of this, which will have the capability to switch between being a fully parallel, which is every battery inside it being in a big parallel array. That could provide up to 150 amp hours. I'm not quite sure yet. I have to do the actual tests and see the capacities, match them together, and all that kind of fun stuff. But in the end, it will have a massive capacity, and they can all be connected in parallel like that, which would be the ultimate version of that plug. You'll be able to plug this light in here and power it for possibly a month even. I don't know yet because I'm yet to actually play around with the device. That doesn't exist because I have to make it exist. But this does exist, and it's doing a pretty awesome job of lighting up the bench here, and also of tripping itself out. I think that's to do with the plug just being a little bit loose. Yeah, it's a bit oxidized. It's an old wire because I've literally just got a bodged on cable here using whatever I have on hand to get it to go. One other final thing about this is the I'll just unplug that because that'll actually provide us with the access point. Now, inside here is a protection circuit which stops it from over discharging, but also provides overcurrent protection. And you see these two indicators actually show the status of the Clipsal circuits, as I call them. It's a DC circuit breaker based on a field effect transistor and a couple of voltage sensing transistors and resistor networks, which will basically check the battery voltage, and if it drops below 3.2 volts or so, it instantly kills the power and stops it from providing power. Oh, I must have just pushed the reset button there. This is set to turn it back on, and the big red button tests or shuts it off, but actually tests the circuit breaking element by shorting out the sensing wire. But report, it's a foolishly placed cord, and then just so take some bad measurements and just whack it and short it, you find that that light is extinguished because instantaneously it killed the power, and it doesn't even make a spark. That's how quickly it cuts off the power. So it is a pretty useful feature to have, especially when you're using dodgily soldered connectors and stuff. It will protect you from any kind of your own fails. So let's bring that light back on, and that's this. Pretty much completely described and swamping out the camera with this bright ass reflection. Now I'm going to put that up over here, which is probably where it's going to live for the rest of the season. I don't know what you'd call it. And I'll bring on to the next thing that I built. And these descriptions are probably a bit quicker, maybe not. I don't know. I tend to carry on because that's just me. Now this is something I've made really recently, and here goes the focus to make it really, really confusing. Let's just see if we can lock onto that. And yeah, it's what looks like something that clips onto a book or some other little desk lamp. It was powered by 4 AA batteries. It was a incandescent bulb in here. But what I've done is, well, I'm going to turn it off because it's going to be really bright, is put my own bulb in there and to make it run on less batteries. And that's all thanks to, well, the very, very blurry, let's focus back in, that's all thanks to this little transformer, transistor and resistor down there, which forms your classic Joule Thief circuit. And that is actually a Joule Thief with a secondary, so it provides a stepped up voltage to this capacitor via a diode, a little mob here to stop things from flying over the top should the bulb break or something like that, which actually did happen. The last bulb I tried in this was this little thing here, which is basically the glass nib from the bottom of a light bulb with the filament LED stuffed inside it and glued. However, the glass kind of cracked when I was soldering it into this base here, and not only that, but one of the board inside or something cracked, and it just randomly would turn off and then back on again, and after messing around with it, it just stopped working altogether. So it's a little bit broken, but that's no problem because I have better ones. Just dig through a tray of components over here. This is how I'm keeping all my components in trays. Well, drawers. They were kept in very, those compartment trays. Yeah, that was a very annoying thing because you have one tray full of capacitors, another tray full of resistors, and then you stack them on top of each other, and then the thing you need the most is always in the one at the very bottom. So, by putting them in drawers, nothing's ever underneath anything else in such a way you can't get to it. Now, this is a 3AG fuse with, you probably can't see it, but now you can, a filament LED stuffed inside of it, which is pretty cool because, well, the filament LEDs themselves, just loose, are very fragile, tend to break, and I don't really want one hanging around inside of a lamp or anything like that, unless it's sealed. They're usually pretty well sealed inside that glass bulb there. And yes, this is where I've got them all from, is these filament lamps that I basically picked up for a steal. Bunnings, the local hardware store, was getting rid of them for a rather cheap price, so I decided I was going to pick up a fair few of them while they were on that clearance. They're all gone now, but I have 20 of them, or had 20 of them until a couple of them, well, let's just say they had to break. And one of them actually did randomly break. One day we found there was glass all over the kitchen floor because the bottom here, mysteriously, there's a line there, maybe it's a defect in the glass, maybe something happened, and it had a perfect crack around the base here, with basically no glass left on it. It just popped off this top glass piece, which fell straight to the floor and smashed into a million pieces, leaving the middle part with the filaments on it just hanging out of the lamp socket, still working and everything, which was rather interesting. But that gave me another 4 filaments to play with, so I wasn't going to exactly complain about it breaking, because after all, I have replacements as well. And I'm kind of looking for excuses to pull the filaments out of them if at all possible. So if I drop one while putting it in a fixture, I'm going to have a field day. And here's some cob strips, which might be the feature of a future video, because I found some interesting lamps that I took apart, and, well, as you can see, I kind of gutted them for their parts. But yeah, we lost focus again? Oh no, we focused in on that transformer, that's right. But yeah, those lamps had some interesting things about them, which I may explain in the future. But this lamp is what I'm trying to explain now, but keep getting distracted. It's an old thing. I mean, it has the most pointless magnifier in the world. I mean, that does not come off. It is literally just swings out and does not magnify at all unless it's freaking, yeah, it doesn't really work that great. But this clip is probably the most useful part, apart from the lamp, allowing me to clip it wherever I want. It actually sits on the back of my computer monitor, hence this Velcro strip, because it holds it on the top, and then the light just kind of pointed over so it shines on my desk. This is so I can see my keyboard at night, because I used to have an illuminated keyboard, and then I spilled a coffee in it, and long story later, I basically have a cheapo keyboard that doesn't have lights on behind the keys, and now I can't see what I'm typing at night, which is rather inconvenient. But yes, this solves that. And refocusing. So there's all the circuitry. I've explained that kind of already. But here's here we go, this darkness. Is one of those fuse lamps just kind of soldered in there. It does have a wire along the back, but for all intents and purposes, you can't really see that when it's just sitting like this. And because it's made out of Joule Thief, I can use 1 battery or 2 batteries simply by using this dead nickel cadmium battery that I shorted to itself to basically, turn on the light. Yeah, there we go. It's going to be bright on camera, but yeah, you can use it either 1 battery or 2 batteries for even brighter light, which is almost too bright. Even with just 1 battery, it's actually good enough for all normal use, I guess. And, well, that's what I made in the past day or two. I think 2 days ago I made this because well, it was originally just the fuse lamp hanging off of the little transformer and some wires on the back of my computer screen, which was rather weird. There's no real further remarks about this little guy, so I guess I'll just put him off to the side because spare on the bottom like that. And the last thing I'd like to show before this video gets too long and the video's file size is too large to upload is this. Your average cheapy multimeter, but with a single AAA battery in it. Because once again, it's powered by a Joule Thief. And that's the thing, those simple circuits can just run an LED, or you can add a couple more components to it and turn it into a regulated power supply, which is what's in here. There is the Joule Thief circuit powering it, and then a transistor and a xenodiode, and a couple of other small components to basically provide a signal when the voltage reaches 9 volts, which will then turn off the transistor running the Joule Thief and cause it to actually regulate its voltage. Without that, the voltage on the Joule Thief just keeps rising. As we all know, Joule Thieves will just produce whatever voltage the load requires, which is why I can literally power this lamp, which those filaments need about 60 volts to run, but I'm running it on a single AA battery, or two if I want more brightness. Because yes, the Joule Thief will just continue to pump up the voltage. You can actually use them as capacitor chargers, which is how the disposable camera works. It basically charges up a capacitor with a Joule Thief until it reaches the absolute maximum it can get to, really. And then a little red light turns on, and yeah, you know it's charged when that comes on. Well, that was rather silly, but you get the idea. Actually, in fact, that light, just to continue the sidetrack, may actually be the regulation, because it only turns on once it reaches the full voltage, and by then the Joule Thief was putting out such a little amount of power that it's all going to go to the LED, the excess. Which kind of happens in here. I mean, that LED actually, there's a little hole there, which does have a red glow behind it. You can, I don't know if you're going to be able to get to see that, because there's all these other lights and stuff happening. But it does glow very faintly, because underneath the xenodiode is actually an LED, which is part of the voltage detection circuitry. And as you can tell, it does do its thing, just battery measure, and you can see that yes, it's not fooling around, or is it? Oh, there we go. So yes, it's a perfectly functional multimeter running on a single AAA battery. And if you can hear that high-pitched squealing sound, that's the converter doing its thing, and it's not exactly ideal. That's because the windings on the core are a little bit loose, and then when I kind of glued it all in there, it's been coupling the noise to the front of the case, so the squealing of that thing actually is pretty prominent. And more glue that I put in, it kind of just doesn't go. That's about it for this one. I mean, my phone has already told me that I've gone through 4 gigabyte files. I don't know how I'm going to put that up on YouTube when I've got a 3.5 gigabyte data allowance. That is going to be a fun thing to deal with. Although I can probably just resize these videos in video editing software. Anything else on my workbench that I can instantly just chat about? Not really. Just a lingering battery hanging around. There is this little thing which I made, that's just a battery shell with a nub on the end, so I can put a AAA in there and convert it into a AA size, which is meant for use with this, which is why it's got a spot kind of in there. So yes, I hope you enjoyed that. I'm not too sure. I have lots of random things that I can talk about and work on, and lots of sidetracking in conversation. But that's just what conversation is. If there wasn't an interesting thing to talk about, it wouldn't be a very interesting conversation. And yeah, well, I hope you enjoyed it, and I will catch you next time.